All right, let's look at the homework 5.6, problem number 7. All right, so we want to find M4 for this function f of y is equal to 9y on the interval from 0 to 2. All right, so let's do that. All right, so as usual, we're going to try to find delta y. All right, and the delta y is going to be, again, b, which is 2, minus a, which is 0, over n, and in this case is 4. So it's a 2 over 4, so it's a 1/2. Right, so that's delta x. All right, so the interval is going from 0 to 2. Right, so 0 to 2. And we're going to split into 4, so that's going to be 1 there. This is going to be 1/2 there. And this is going to be 3/2 there, right? All right, then we just have to find a bunch of midpoints. So let's find midpoints. Here, between 0 and 1/2 is obviously 1/4, right? Add them up, divide by 2. And here, between 1 and, let's see, 1 and 1/2, so it's going to be 3/4, right? And the next one is, let's see, 5/4. And next one is 7/4. So once you find that, x1 bar, I just keep on adding 1/2 to it, or 2 over 4. So you get 3/4, 5/4, and 7/4. All right, so we got that. Then all you have to do is we're just trying to approximate this integral, right? So you have an integral. Interval is going from 0 to 2. And the function is 9y and with respect to y. So we are trying to approximate this guy by M4. All right, so let's do that. All right, let's open up a GeoGebra. All right, so we have, let's see, a function f of, the GeoGebra understands x better, so I'm going to use x instead of y. So you have, I'm going to write 9x, all right? So we have that. All right, then we want to have, let's see, so we're going to add f of first midpoint is 1/4. Plus second midpoint is going to be 3/4. Plus f of 5/4 plus f of 7/4, and then multiply by the delta y is 1 over 2, right? And I hit enter, right? So it came out to be 18, right? So let's type it in, right? So we have, not the exact one, 18. So type in 18, right? Let's check the answer. All right, I came back and looks like we got this one correctly. All right, then let's find the exact value, and you can actually just use the evaluate this definite integral by hand, but I'm lazy, so I'm going to use GeoGebra here. All right, then I'm going to use a command called the integral. Right, so already have a suggestion. I'm going to use this third one. Right, so integral. Right, so function is f. Right, starting value is 0, and the ending value is 2, and I hit enter. Right, so we can see that here. Maybe I should look at the picture too. The picture isn't exactly the same because I'm using x instead of y. All right, but the area came out to be 18, which happens to be exactly the same as the M4 value. So, this approximation actually gives you the exact value. All right, so let's check this answer. All right, I came back and looks like we got the exact value area correctly as well. All right, But you can see that you might be surprised that the approximation was actually exactly the same as the exact area. The reason is this. You can see that here, using this rectangle, you're actually missing this much area, but you have this extra here, which happens to be exactly the same. So you're missing a little bit, but you have this extra to compensate that. And the same thing happened to each rectangle. Here you're missing something here, but there's extra missing, and here's extra, same amount. Missing something here, but you have the same amount extra there. So they all cancel out. So error, it happens to be actually 0. So you get the exact answer here. All right, that's it. I hope that this was clear.